is trig, okay? We're going to start to kind of take something like a circle and overlap it with triangles. That's basically the idea behind it. So eventually we get into sine, cosine, tangent, like that kind of stuff comes into chapter 4. Chapter 4 is a beast of a chapter. We'll divide it in half to take a test. But today we're just going to lay the foundation on like some of the vocab and some of the understanding, and then we'll continue to build on it on Monday. So first of all, this is obviously an angle, okay? The initial part is where that angle starts, and the terminal side is where it ends. So if there's no arrow drawn, then we assume it goes counterclockwise, okay? But also this angle can go clockwise, which would have a negative value, but that one you would see an angle drawn, okay? But it is important to know where's the terminal, where's the initial and where's the terminal? Because especially you'll start to see, it'll say like something about the terminal side of an angle. You have to know that means that's where that angle ends, okay? Positive, like I just said, positive is generated by a counterclockwise rotation and negative by a clockwise rotation. So if my angle starts, and in standard position, they will always start at your x-axis on the right-hand side. We would say this is 0, and then it would go around your circle in this way if it's positive. This would start at 0, and it would go around the circle this way if it's got a negative angle. So let's talk about a little teeny tiny bit about a radian. So a radian is just a unit of measurement. And this throws a lot of people off, okay? But it is just a unit of measurement. It is what happens if I have a circle, okay? And I know that the radius, let's say our unit circle has a radius of 1. Then we can take the circumference of this circle, which is the measurement around the outside, right? Or the perimeter of the circle. And we can adjust it to what's called a unit of measurement of a radian. So if I had a circle and I wanted to find the circumference, how do I do that? Do you remember how to find the circumference of a circle? Nope, that's area, but you're warm. 2 pi r, or what's 2 times r? Diameter. So you can also do pi d. Those are both units. That's how I find the circumference, which is the perimeter of a circle, yes? So what happens if that circle has a radius of 1? Now what's the value all the way around my circle? If that r is 1, 2 times pi times 1, yes? My entire circle is 2 pi. Do we understand that? Yeah. All the way around the circle, the value would be 2 pi. That is how we measure radians. We actually take the r, we make it 1, and we keep it sometimes in terms of pi, but also we can estimate pi to be 3.14. So the entire distance all the way around my circle would be 2 pi, which is the equivalent of 2 times 3.14, which is the equivalent of 2.628. So one full rotation all the way around the circle is that. Okay, and that is how we measure radians. We actually put it in terms of the arc length all the way around the circle. So if I wanted to find something that was half the circle, then I can take my circle. So let's say I take my circle, okay? And I know all the way around from start to finish is 6.28 radians, okay? Half the circle would be half of that, right? So from here to here, so this was 2 pi. The blue would be pi, or 3.14 radians. So it might ask you to say, like, where is pi? Or here's an angle, what's the measurement? It's halfway, that is pi. But it also could say 3.14 radians. So pi can be in your answer, but also be substituted by the actual value of pi. So if I ask you to find what is 2 pi, for me, the easiest way to do it is imagine half my circle is the 3.14, which means a little bit less than 3.14 is going to be 3. So like 3 might be here. And then if I take from 0 to 3 and divide it into 3 parts, this would be 1, this would be 2, approximately. And then if I take that and go across my circle, this is 4, 5, 6. So when it asks you to approximate something that is 2.5 radians, I would have to know that that's kind of in the third quadrant of my circle, okay? It's an approximation, but I would need to know around about where it is. Some of the questions are going to give it to you in that kind, but most of them are going to be in terms of pi. So it might say pi over 2, pi over 3, pi over 6, 2 pi over 3. We're going to learn all those angles, okay? But in the beginning, it could just give you something that says, draw an angle that is 3.5 radians, and you have to know how to approximate where that is, okay? So again, we'll revisit it when we start to graph, but that is one of the most important things at the beginning. If you can understand where those whole number unit of radians are. We're going to start to build the unit circle in terms of pi. So the way we do this is all the way around my circle. We just said it. All the way around the circle is 2 pi. So the very first angle on the right-hand side, it starts at 0, but then it comes all the way and doubles back around at 2 pi, which means half my circle is pi. And then if I take each of the top and the bottom quadrants or halves of my circle and I cut those in half, the top would be 1/2 pi or pi over 2, and the bottom would be 1 1/2 pi or 3 pi over 2. So we're gonna build in all the angles in between on Monday, but we're gonna just start the understanding of what this is. So a full circle starts at 0, goes all the way around to 2 pi. On the left is pi because it would be half of 2 pi. At the top is 1/2 pi or pi over 2 because it's halfway between those. And on the bottom is 3 pi over 2 or 1 1/2 pi. Again, we're going to fill in all the angles in between, but we're going to start with these are called our quadrant angles. In this example, it's asking you to draw and label each angle in standard position and then state which quadrant the angle lies in. So we always start with our XY axis. We always start with the angle in standard position being on the right-hand side of the x-axis. So where did we just say 3 pi over 2 was? At the bottom. So this is going to go all the way around, and that would be this. These are all Greek symbols. This is some good college prep for you that are joining fraternities or sororities. We're going to learn some Greek letters, okay? That little guy that looks like a Jesus fish is alpha. And then B, that one that looks like a B, is beta. And then C, probably the most popular one, that O with a little squiggle through the top is called theta. It's probably the one we'll use the most, okay? So that is 3 pi over 2. What did we say 2 pi would be? All the way around. So it starts here, it goes all the way back around. This would be 2 pi. And now 7 pi over 4, we didn't talk about. That's not one of the quadrant angles. But take that number. It's improper, right? 7 over 4 would be improper. Put it in mixed number form. So 7 over 4 becomes what? 1 3/4 pi. Where's that going to be? Think about it. We have 0. We have 1/2 pi. We have 1 pi. We have 1 1/2 pi. And we have 2 pi. So where's 1 3/4 going to be? Fourth quadrant. So I'd start it here. I'd come all the way around and stop it there. That's theta. So for right now, again, we need approximations. We're going to eventually fill all that stuff in. Questions so far? Okay. Coterminal angles are angles that in the standard position that have the same terminal side. So there's no limit to how many times you can go around the circle. You could go around once, twice, 3 times, whatever. There's no limit. Every time you start at 0 and end at the same spot, those are called coterminal angles. So if I graph something that was pi, let's say, I could also graph something that is 3 pi. 3 pi starts here. This would be 1 pi. This would be 2 pi. This would be 3 pi. Starts and stops the same place. So these are called coterminal angles. 5 pi would start here. This would be 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. Also starts and stops the same place. So these are called coterminal angles. A coterminal angle is found by adding and subtracting 2 pi. So if I ask you what the coterminal angle is on pi, if I add 2 pi to it, I get 3 pi. That's a coterminal angle. If I subtract 2 pi from it, I get negative pi. And remember, negative just goes the other direction. So negative would start here and go to negative pi, which would be here. They start and stop the same spot, which means they are coterminal angles. All right, let's do this one and then let's stop. This says find two positive. Actually, we're going to find one. One positive, this wording is weird. One positive and one negative angle that are coterminal to the given angle. So if I want to find a positive one, and if it's negative as it is, obviously I need to add, right? I can either add or subtract, but if I want it to get positive, I'm going to add. So I'm going to add 2 pi to this. And then I'm going to change it so it has the same denominator. So negative 3 pi over 4 plus 8 pi over 4 becomes 5 pi over 4. That is positive, and it is coterminal. If I want to find negative, I can subtract 2 pi. So negative 3 pi over 4 minus 2 pi, or negative 3 pi over 4 minus 8 pi over 4, which is negative 11 pi over 4. That is the another coterminal angle, okay? Again, there's an unending amount of coterminal angles, but if it asks for just one in each direction, you can do that. There will be times in which your value is so small, like let's say it was negative 10 pi over 3. It's so negative that when I add 2 pi, it's still negative. Then I have to add 2 pi again to get a positive one. In order to give a positive coterminal angle, my answer has to be positive. So sometimes you might have to add 2 pi more than once, or sometimes you might have to subtract 2 pi more than once if it's so big you can't get it to go negative, okay? All right, let's do B, and then we'll stop. So what am I going to do to get a positive one? Add 2 pi, which it becomes 12 pi over 6, and I get 17 pi over 6. And then subtract 12 pi over 6, and I get negative 7 pi over 6. Good? Okay, we're going to stop.